Hi everyone, and welcome to the next lecture in the series referred to as Digital Humanities Lunch, which has quite a long history already. So our next speaker today is Dr. Petr Plecháč from the Czech Academy of Sciences in Prague, from the Institute of Czech Language. Oh, Czech Literature. Oh, okay. So for the literary studies. From Prague, and he'll be presenting a paper on versification and authorship attribution with very big names as authors, such as David Bergholm or Archie Michela, another person I know. So welcome, and the floor is yours.
Thank you. Okay, I will start with and why even to use versification, or why I do think that versification should be used in the process of authorship attribution. Then I will describe in detail some methods such as Barrow's delta, support vector machine. I kept this presentation really simple, so please stop me anytime, and if I will spend 20 minutes with Barrow's delta, don't hesitate to stop me and tell me we've heard it 100 times, we know what's going on, and we can spare some time for to show, for instance, how these versification features may be grabbed from a text. And then I will present, of course, the evaluation of the model. So, just a very elementary introduction. The most frequent task which we encounter in authorship attribution is the situation that we have a text of unknown or doubted authorship and a set of candidate authors. And contemporary stylometry has developed extremely accurate and sophisticated methods for solving such tasks. The logic behind them is to tell the author by measuring the degree of stylistic similarity between the text in question, between the target text and particular text written by candidate authors. And for this purpose, various different style markers are being taken into account, such as frequencies of words, frequencies of parts of speech and different grammatic categories, frequencies of character engrams, frequencies of word engrams, or to say collocations. However, it seems to me that one feature, or one important set of features in, of course, one important form of literature, which is a poetry or versified poetry, is not being taken into account, even though there are strong arguments why we should deal with it, why it should be considered as a reasonable style marker. So to mention just few reasons why I do think it's worthy to deal with versification. First, that most of the features used in stylometry, such as frequencies of words, engrams, or other such features, represent what is known as statistics as a rare event. It's something occurring once in, thousands of times, or at least 100 of other occurrences. Therefore, rather large samples are required. This is working great with novels. This is working great with the fiction. The thing with poetry is that in practice, we are not usually dealing with the book of poems where the authorship is unknown. We are dealing with a single poem, or if we are lucky, with some, dozen of poems published in some journal or somewhere. But we are dealing with a really small samples. But versification features are usually Boolean, 0 or 1, true or false. For instance, in meter or in rhythm, we distinguish simply stress position and unstressed position, at least in accentual verse such as Czechis. But even if we are working with the Spanish poetry, which as Polish poetry is syllabic, it brings a really huge amount of information. So these features are usually Boolean or may gain only a limited number of values. such as types of rhymes, for instance. There are few types of rhymes which a rhyme can can be. The second reason that versification is or should be much more topic independent than lexical features such as words, because vocabulary may change a lot across poems of different genres written by one author. Of course, there are many methods how to make the analysis of words much more topic independent, how to throw away the topic independent words, but still versification feature seems to be much more stable, or at least we can state a hypothesis that versification of one author across genres is much more or less stable, disregarding if it's a ballad or if it's a sonnet. Also, some say, and here keeping specifically Boris Tomaszewski in mind, that rhythm is more complicated to forge, which is something we may doubt, but he says that you can imitate Pushkin's vocabulary. You can use Pushkin's words, but it's really hard to imitate his specific sound of verse. And finally, some stylometrists propose to combine different features in a single analysis, like to combine vectors of most frequent words, character engrams, and word engrams. The thing is that I'm sorry, is this font large enough? Is it possible? No, not at all. Okay, let's try it. This way. Is it better?
Yeah.
Frequencies of these features are strongly correlated. Basically because, you know, words are formed by engrams, their frequency will inevitably be strongly correlated. But once again, on the other hand, versification brings something completely different, something where we have no reason to expect that these things will be correlated somehow. And this brings us to my hypothesis that combined analysis of lexical features and versification may be more powerful than the analysis of lexical features themselves. So here, this is a very, very, very brief sort of chart showing or showing very brief history of stylometry of authorship attribution problems. Of course, many things are missing there. What I would like to point out is usually Mendenhall is mentioned as the the founder of quantitative methods in authorship attribution. What is not mentioned so often is that even 100 years ago, before Mendenhall, there were attempts to use versification, to use quantitative methods to quantitatively approach the versification and use the results for authorship attribution. It was associated with the Shakespeare studies, with the questions of which works are written by Shakespeare and which are not. This include Malone, I really don't remember the first name, and his argument was on the very beginning of 19th century, and especially in the late 1980s, so-called New Shakespeare Society. Of course, if we take a look into these texts, they seem very naive. There are simple rules such as if 50 or more % of lines ends with stressed syllable, it's Fletcher, otherwise it's Shakespeare, or so on and so on. Yeah, but still, I do believe that if someone opens this presentation after 200 years, he would find it very naive as well. So, versification, we may say that it was very first feature employed. In the 20th century, however, versification is being somehow abandoned by mainstream stylometry. in favor of lexical and syntactic features. Grief, I think, says that it's probably because these methods of New Shakespeare Society was so bad and so naive that no one was interested in that anymore. And stylometry is becoming much more advanced in terms of statistics, in terms of classificators and mathematics behind it. It used in last years machine learning models are used. On the other hand, in 20th century, that still was versification was still being used to solve tasks on authorship attribution. But just behind the scope of stylometry, this was done in so-called Russian school of metrics or Russian school of versification studies, which follow the line of Russian formalists. It's just Tomaszewski has some cases, so I think he's dealing with some Pushkin's work there. Shakespeare, Yuri and Mikhail Lotman has also some articles on the authorship solved or being approached through the versification. And of course, the main person here is Marina Tarlinskaya, the Russian-born expert on versification, but being in the United States for the last several decades. And she wrote several books on the authorship of Shakespeare, where she's using precisely the versification features as an argument. The thing is that in 20th century there was a big gap between more and more advanced stylometric methods based on multidimensional statistics and these studies on versification that were provided by versification experts and which remains with rather simple, descriptive statistics, and they didn't make. Actually, the methods remains the same, as I will show, as it was in Mendenhall's case, in the very beginning of the 20th century. So. I will show you an example from Tarlinskaya, how she approaches Shakespeare authorship, and then the famous study of Burroughs, where he proposed Burroughs delta to compare the method, and then we can take a look on how to combine these things. And this is the case of Henry VIII, which is the 17th century play, and where most scholars agree upon. It's a collaborative text that was written by John Fletcher and William Shakespeare, and they agree upon which parts were written by whom. Tarlinskaya, in her book from 2014, attributes these parts by means of diversification, namely by distribution of what she calls strong syntactic breaks after particular metrical position. I do believe she doesn't give a precise definition of what she means by strong syntactic break. Her argument is that part A and part B, or parts A and parts B, differ in whether the peak of the distribution of these strong syntactic breaks is after the 6th or the 7th syllable. And also she argues that the individual values are similar to those found in other texts from the very same period. They were written like a year or two before, which is Fletcher's Bonduca and Shakespeare Tempest. So these are data from Tarlinskaya. These are the parts A of Henry VIII. And these are the parts B. And these show the frequency of strong syntactic breaks after the 2nd, 3rd, 4th, and so on syllable. These are values found in Fletcher's Bonduca. And these orange ones are values found in Shakespeare's Tempest. And basically what Tarvenskaya says is, take a look, part A has a peak here, precisely where the blue, where the Plecháč has a peak. Parts B have a peak here, and that's precisely where Shakespeare's Tempest has a peak. And she says, and if we take a closer look, the curves are really similar. The blue one to the parts A and the orange one to the parts B. If you remember Mendenhall's study on authorship of Shakespeare based on length of words, this is precisely the same method. Precisely the same method, comparing the curves, just judging by the eye. Not even that this is a very reliable method. It hardly can be used when we are dealing with 100 of features or 200 features. And yeah, the main problem is that despite these data are being multidimensional, there are more than one number. Tarvenskaya is comparing by the eye the individual values, not the entire sets to each other, but the individual values. Let's take a look how Burroughs deals with the same situation. And please, at this moment, stop me anytime you think this is something we heard 100 times before. So this is a Burroughs article from 2002 or 3, I believe. And we have there a model situation. We don't know who wrote the text called Paradise Lost, but we have a strong evidence that one of these 25 authors did it. The question is, of course, which one? Delta aims to give an answer in the following way. We grab some amount of words and words that are most frequent in the entire collection, in this entire corpus, and then we compare the frequencies of these words in candidate text to those found in Paradise Lost. So far, it doesn't differ from Tarvenskaya. The thing is how Burroughs deals with comparing the entire set, not the individual values. So these are the values of 20 most frequented words in Paradise Lost. No, sorry. That's why the peak is over here. Not this is sorted by the frequency in entire collection. That's why the first one has not the highest frequency in Paradise Lost. So these are the values of B and of A2 in his and so on. These are the values or the frequencies of these words found in another Milton's work, and these are the values found in Aphrodite in another poet work. What Burroughs suggests is a very intuitive method how to compare these two sets. For each candidate text, we calculate the distances, the difference between its individual values and the ones found in Paradise Lost. So this shows, the distance of Milton to Paradise Lost. These lines, these are the distances or the differences found between Paradise Lost and Aphrodite. In practice, there's one important step is the transformation to z-scores, but let's keep things simple and deal with the frequencies themselves. So basically, what Burroughs suggests is simply to sum it up. Sum up the differences, and the final number final number shows which one is closer. And the result is as expected. John Milton is closer to Paradise Lost than Aphrodite. And these are the results for all 25 authors, showing there's a Milton, then there's a sort of gap, and then the other authors. So it works as we expected. In 2007, Shlomo Argamon, American computer scientist or data scientist, mathematician perhaps, pointed out that Barrow's delta correspond to what is known in mathematics as measuring the Manhattan distance. That what Barrows came to by intuition, led by intuition, is actually something that that is known for a long time in mathematics or in data science. In the same article, he proposed an alternative, or one of the alternatives, based on measuring not the Manhattan distance but the Euclidean distance. Finally, just from all the alternatives that were proposed, I will mention the one based on measuring the cosine similarity, and I will illustrate it, or will try to illustrate these principles of these three metrics: Manhattan distance, Euclidean distance, and cosine similarity, with a sort of real world example. Okay. Here we have a Manhattan, from which Manhattan distance actually got its name. From its grid of streets and avenues. And we have a Chelsea Hotel here and Empire State Building. And the Manhattan distance simply tells what distance a person walking from Chelsea Hotel to Empire State Building has to make. It's if he's walking on the 7th Avenue and then this, I don't know what number street, and you sum it up. This is precisely what Barrow's delta does. It takes the distances along each dimension and sum it up. Euclidean distance is nothing else but the most straightforward way from this point to the second point, and it is clear that using Pythagorean theorem, it may easily be calculated from these two values. Finally, cosine similarity may be roughly described as an angle of some distant observer. You can imagine it as someone standing on the top of the Statue of Liberty, watching these two buildings, and he's seeing them in some angle. And to this observer, maybe what's here? Hard Rock Cafe, for instance, would seem much closer to Chelsea Hotel than the Empire State Building, which is not true, of course, in terms of other metrics. So, and there's no reason to stay with the two-dimensional space. We can move to three-dimensional space and ask for the same task: how to get from the Chelsea Hotel to the very top of Empire State Building. And the principle remains the same. We get a person walking on Avenue Street and then taking the lift. We sum up these distances and we have a Manhattan distance. We have a Euclidean distance, which may easily be calculated once using Pythagorean theorem. Once again, we first used Pythagorean theorem to count this distance, and then we have a new triangle. So it's a simple mathematics. Finally, there's somewhere Statue of Liberty and a guy watching it in some angle once again. Now, if we stop thinking about the buildings in Manhattan and imagine each point as a data point with the values of first and second and third most frequented word in a paradise loss or in a corpus, paradise loss on a candidate author, we got this precise method how to count it. Difference between frequency of first word, second word, third word in those texts, sum it up, and we have Barrow's delta or Manhattan distance, and so on. And even though that more dimensional space goes beyond human imagination, the principle remains the same for 20, 50, or 100 most frequent words. We just sum up the distances to get Manhattan and do some more calculation to get Euclidean and cosine similarity. Finally, I would say a few words on support vector machine, which is kind of different approach. It's an instance of supervised machine learning, which means that the algorithm use labeled training data, labeled according to classes, labeled according to who wrote which sample, and he used it to infer some classification function for new data. He used this to learn a function which will enable it to use it for classification of new data where labels are unknown. So, model situation, once again, we have a text of unknown authorship, target text, and a set of 20 text samples from each of two candidate authors. Author 1, which is the orange one, and author 2, which is the red one. And then we have a target text here. And yeah, x-axis show the frequencies of most frequented words. First most frequented words, let's say the, and the second one shows the frequency of second most. The y-axis shows the frequency of second most frequent words, which is and. These are being transformed to those that score, so that's why the frequencies are going below 0. What support vector machine does is that during the first phase, during the learning phase, it takes as the input data from author 1 and author 2, which are being labeled, and tries to find a function which correctly separates them with respect to these labels. This is done using a so-called hyperplane, which is a subspace of one dimension or less. In two-dimensional space, this means simply a line. And during the second phase, during the classification phase, this function is used to classify the target text, the new data. As you can see, there are infinite numbers of such lines that you may use to correctly separate orange data points from the red data points, and use them to attribute to the target text to author 1 and author 2. You see this, when using this line, we will classify this as the text of author 1. When using this line, we will classify it as a text of author 2. So what support vector machine does is it chooses the line that maximizes the distance to the nearest vector, to the nearest data point on each side. These distances are the maximum possible from all the lines that we can make there. And this function simply classifies this target text as a text of the orange author 1. And this example is, of course, very elementary one. Not only we need to deal with data of much higher dimensions in real attribution, we don't work with the first and second most frequent word, but in vast majority of cases, we face the data that are not linearly separable. We have red and orange points so mixed that there is no line that can separate them. And of course, we also need multi-class classification. We are not asking only whether this or this author, but we have a set of 10 perhaps authors. And the ways that support vector machine deals with these issues is extremely complex. It involves adding or converting the data into more and more dimensional space, bending it somehow, and I really don't want to pretend I fully understand the mechanisms, the mathematical grounds of these. But it's implemented in several Python libraries or in other programming languages. And if we know this basic principle, the usage is pretty much straightforward. So finally we get through the versification. And the question is, of course, if we are able to tell the author just on the basis of these features. And I believe the method is clear now. We don't use comparing the curves, Starlinskaya did, but we simply use frequencies of these versification features in modern classifiers used in stylometry. Namely, I've employed here Manhattan distance, Euclidean distance, cosine distance, support vector machine. And for this experiment, I have used 4 different corpora. First is being the corpus of Czech verse, which is built in our institute. Second is a German corpus called Metricalizer, which is being built in Freiburg by Clemens Bobenhaus and Benny Hammerich. Third, the Spanish one is corpus of the sonnets of the Golden Age, of Spanish Golden Age, being built in Alicante. And finally, a rather small English corpus of rhymed poetry, which was built and published by Sravana Reddy and Kevin Knight for the article on automatic detection of rhymes. It was not metrically annotated, means that we had no clue which is iambic, which is trochaic. Stresses were not marked there, and this annotation, which is in all the other corpora, was done with the help of Ryan Heuser and his prosodic Python package, which was extremely helpful and, to my eyes, extremely precise in classification of various meters, verse meters, I mean. So, what features were used for the analysis? I use different. Of course, this poetry differs in formal aspects, so that's the first reason why we can't use the very same set of features. In Czech, we were dealing with the trochaic tetrameter, with the trochaic lines, both masculine and feminine, and something that in versification studies we call stress profile, which is a very simple data. For instance, in this masculine trochaic tetrameter, which is 7-syllable long line, you simply count the frequencies of stress on first syllable in a sample, on second syllable, and so on and so on. So when you're dealing with masculine and feminine tetrameters, you are having 7 and 8, giving 15 values characterizing each samples. And the second one was a sort of approximation of what we may call euphony, or how this author is dealing with the frequencies of sounds. And this was done simply as a profile of sounds found in a phonetic transcription of these texts. We did the very much same in German corpus. Just to say, German and Czech versification are pretty similar. But we did it only with the trochaic tetrameter with feminine lines, because there were not enough masculine lines to analyze. And that's why we add also some characteristics of rhyme to have a larger set of features. This include the frequency of vowel length match, how often the length of a vowel in a rhyme pair is the same. Closed rhymes, or in other words, rhyme ending with a vowel or with the consonant, and then simply vowel pairs and consonant pairs, or consonant cluster pairs in a rhyme. In Spanish versification, it's much more easier because Spanish versification is syllabic. It doesn't distinguish between trochees and iambs. And there's a dominant 11 syllable lines long verse. So we simply took all these 11 syllable lines, which were like 98% of all the lines there, and we did the stress profile. We counted the frequencies of stress on each position and also the frequencies of sound. And finally, we did the very same with masculine iambic pentameter in English. We did the stress profile of this and also this approximation of euphony, of frequencies of sounds. Now, the evaluation was done in the following way. In each corpus, we took the samples of same size. In Czech, German, and English, it was 100 lines. In Spanish, it was 98 lines because it corresponds to 7 sonnets. And the Spanish corpus consists only of the sonnets. So we've extracted it and in a way that each sample was written by one author, and no poem was divided into 2 or more samples. And then we've performed in each corpus the leave one out cross-validation, which means that you have this corpus of samples. You grab out one sample, then you let the model train on the data, and let it guess who is the author, and so on with other samples until the end of the corpus. And then the evaluation simply says what percentage of these samples were correctly attributed to the author that wrote them. This way, we've grabbed some 275 samples written by 21 authors, 142 samples from German corpus written by 8 authors, over 350 samples from Spanish corpus written by 10 different authors, and 140 samples written by 12 authors. These numbers says what is the value of random baseline for these samples. It basically means if we were doing this attribution by a chance, we would simply attribute a first author that would be picked by a chance, randomly. What would be the most probable success rate? What would be the most probable accuracy? So in Czech, we would most probably correctly attribute only some 6% of samples, and the value is a bit larger in other corpora, just because we are not dealing with so many authors there. This is the list of all the authors and the numbers of the samples. Finally, for this experiment, we've used following features. We used versification, as was described before, words, or more precisely frequencies of 100 most frequent words, frequencies of 100 most frequent character trigrams, and finally a combined vector consisting of all these data, mixed versification words and trigrams, and we applied it to each corpus, and we tried to process it with all the methods mentioned so far, with Manhattan distance, Euclidean distance, cosine similarity, and support vector machine. And these are the results. These are the results for versification alone in Czech corpus, and it's not really bad. The best performance is with the support vector machine, which is some 77% of accuracy. When we compare it to words, we surprisingly get even slightly better performance with versification than with words in these samples. Even though I expected trigrams to perform better than words in Czech for several reasons, it's simply not true. It was outperformed only with the cosine similarity, and it did not outperform versification. And these are the results when we take the combination of these three, of versification, of words, and of trigrams. And as you can see, the best performance is with the support vector machine. And at the same time, within each method, the combined vector has a better performance than anything else alone. These are the results for German corpus, which are not that good, but still we have some 64% of accuracy with support vector machine when we are dealing with versification. These are data for words. It outperforms versification with these two methods. These are data for trigrams, which are even better. But once again, the combination of the combined vector once again performed the best of them all. With the Spanish corpus, versification performs very good. With support vector machine, we get some 87% of accuracy. It is more or less comparable to the analysis of words, or slightly. Yeah, this is a tiny difference. Trigrams are slightly worse, and once again, this is the same situation which we encountered before. Combination of features gives the best results of them all. Finally, for English, this is the result for versification. Once again, not bad at all. It's far above the random baseline. It means that it gives some information. These are the values for words, which are really hard to beat. It's a 95 for Manhattan distance, 90, almost 98 for support vector machine. Slightly worse for trigrams, and once again the combination, even by tiny difference, it gives the best performance of them all. It's the value is 99 for combination and 98 for words. So this brings us to the conclusions. The success rate of versification is significantly higher than the value of random baseline in each corpus. This means that versification may be considered as a reasonable stylometric indicator. The success rate of versification as compared to words and trigrams varies a lot. It is significantly higher in Czech, slightly higher in Spanish, slightly lower in German, and significantly lower in English. In English, what comes to my mind, this may be the case of overfitting, because in English corpus we are having large poems such as Childe Harold or Paradise Lost, perhaps, is there, chapters of which are being considered as a single poem. So if you are working with the attribution of one chapter of Childe Harold, the correct answer, it was written by Byron, does not necessarily mean that it was that the model is well trained to recognize author. It may be simply a consequence of a decision which may be described as this is written by Byron because it is similar to other parts of Childe Harold, and they were written by Byron. And you know, when there are many characters, places of the same name in the very same work, it may be considered a case of overfitting, because when this model is trained on Childe Harold, it will probably fail when it will encounter other unknown works of Byron. But this is just a hypothesis. I didn't inspect it in detail. So when comparing the methods among the same feature or set of feature, in each corpus, support vector machine gives constantly best performance of all these methods. I didn't include it in the chart, but I was also doing this with the random forest and naive Bayes classifier. And I didn't include the results simply because support vector machine outperformed there in all the cases. From the delta family, from the distance metrics, cosine similarity usually shows the best performance. And finally, combination of features shows always better performance than the given features alone in each corpus with each method. Final conclusion, versification is an important style marker, strength of which is comparable to those traditionally used in stylometry. It may and should be employed in the process of authorship attribution of poetic texts. So, thank you very much for your attention. Presentation may be found online at this address. Code written in Python, which is nowadays pretty outdated. I will upload a new one soon. May be found at GitHub, and of course I will be extremely happy if you will email me anything. Thank you very much.
Thank you very much for this insightful talk, and I'm sure there will be some questions. That's the right moment to ask.
Well, first, very obvious question. Do the differences between the success rates between languages hang on simply degree of freedom in use of verse in different literatures? I mean, in Czech it works quite well, in Spanish it works quite well, in both Germanic literatures not so well. Does it mean that that simply Czech and Spanish versification is not as strict? I mean, the rules of versification are not as strict. And another question, just for clarification, could you please? I'm sorry, but I didn't grasp the method of simply taking the discriminators from versification. What was the exact procedure of coding the features of versifications in versification into the, turning them into discriminators?
So the first question, in a slightly different way, I was thinking about this. German versification is generally very close to Czech versification, much closer than to English one. For historic reasons, the Czech versification, Czech language was strongly affected by German. So German versification is really close to Czech one. What I was thinking about is, okay, why does this stress profile, even the stress profile alone without frequencies of sounds, some 11 values, works perfectly good for Spanish corpus. 11 values. I was wondering, perhaps it is because in Czech versification, in German versification, in English versification, you are not free to place stresses where you want. You have, it's a syllabic accentual poetry. So in case you want to write a trochaic verse, you are not free to place the stresses anywhere you want. Of course, there's a place for variability, but it is small. And I thought, okay, so in Spanish poetry, they are free to place the stress anywhere they want. So it gives them more freedom and, to say, more freedom for author to express himself in a rhythmical way. And so the rhythm of poem may be more individual than in those syllabic accentual ones. But then what I did was I counted the variability of stresses, stress and unstressed syllables at each position. And it turned out that for Spanish it's very same as for Czech. No matter that they don't have trochees, it's probably because something inherent to the language itself, the position of stress in Spanish language. the average length of a word in Spanish language, but it was found that my initial hypothesis was false. There's no higher variability in placing the stresses in Spanish verse than in Czech, where it is controlled by a meter. So I still don't know. What I'm surprised by is the difference between Czech and German. I really don't get it, because these versifications are so similar in many aspects. You know, we have a stress, initial stress, as Germans do. Yes, it's yeah.
Actually, the only Czech is, I think, from these four languages, only Czech is with a fixed stress position. Yeah. In the other ones, the stress is more or less moving along the word.
Yeah, but
more or less.
It's very moving in English, and it's slightly moving in German. So, but yeah. So my answer is I can't tell yet what the difference made, or what caused the difference, and it's also maybe a difference between samples. You know, if we perform it in 100 times or on 100 different sets of samples, we may come to completely different results. So I wouldn't say that this might say something in general about the performance in language. But to the features, so the stress profile, I mean, you have a sample consisting of, let's stay with Spanish, of 11 syllable long lines. And what you do is simply count the percentage of stresses on the first syllable. So
we've got 11 features, right?
Yeah, for 11 syllable long lines, you get 11 features.
What in the case if you've got this Bézier pairs or something like that?
Yeah, that's a drawback of this method. You have to work with the
This is isosyllabic versus.
Yeah. Of course, with truncated parameters in Czech, we were dealing with both masculine, which means 7 syllable, and feminine. This means 8 syllable. So of course, we had to treat it separately. So we got 15 values, 7 and 8. And the frequencies of sounds is simply the frequencies of particular sounds.
So we've got a combination of the stress features and syllabic features. So you've got 11 features for the syllables, if they are stressed or not, and then some features for what vowel was at the end, right? Or rhyming vowel, something like that.
With this, with the rhymes, we were dealing just in this case just with the German corpus. These frequencies of sound is simply the frequency of each sound in entire text. So we've got
sound means letter in practice.
Yeah, but you know, it's not so different in Czech, where the orthography and the phonetics are really close, or in Spanish, but it's a huge difference in English.
German, did you transcribe it or?
Yeah. Or each of these corpora is phonetically transcribed. In German and Spanish corpus, this was provided by the authors, as well as in Czech. I mean, it was done automatically, not manually. In English, this was done using this prosodic package of Ryan Heuser, which is a tool, you know, for annotation of rhythm and meter in English poetry, and it involves, of course, the phonetic transcription of the text itself.
Questions?
Yeah. Okay, in Stylometry we always have at least one variable to manage, so let's talk about another one. Do you think your results would change a bit? I mean, that's just guessing. If you took different corpora from your 4 languages from different literary periods and tendencies? because of course that is huge. I mean, the historical chronology is a huge thing in versification, and so I guess, I mean, you didn't say that, but we have to be very careful what you said. So Czech guesses nicely and German sucks.
If I may follow up, because that was my question to ask. Okay, in the corpus of English, which was performing very well, you had the examples by Dryden, so the 17th century, and from Wordsworth from the 19th century. And this fact alone makes it very, very simple to guess, right? Whereas in
there's a whole revolution in the
yeah.
Yes.
In the case of Czech, I guess this is the 19th
So
century.
what was the Czech corpus, by the way?
In Czech corpus, it was even closer. This was some books published between, I believe, 1810 to 1910, 1810 to 1830. It was 20 years. It was these were really close. Yeah, I really don't want to generalize things here. My main goal was.
But that makes sense in a way, because if you have a short span, then we really know what we're talking about. So that's good, right?
Yeah. In Czech, they were really close. But once again, I'm not yet in a position with this project to say something general here. My main goal was to show within the same sample how does these features perform when you compare it. So what I would like to stress is versification is pretty good when compared to words. And when we combine it, we get even better performance on the very same set of samples. Of course, it may differ a lot when we take another samples. And sure, this is the way where we would like to go to make these results to allow at least
Just from
generalize
and
these
from
results.
more data. Yes. And actually, I have a good news for you. I've just reviewed someone's paper who scraped Project Gutenberg for English language poetry, and I think they're ready to share their big poetry
Really,
corpus. So you don't have to do it.
that would be.
So if we in touch, I can probably. I'm not sure I can. Is it?
I'm not the president.
Paper that I just reviewed today. I was late to the meetings. Anyway.
Yeah, they definitely will wait for the publication of this.
Questions?
Yes, so actually my question will also be to Corpa, because I'm not really familiar with the names, and I don't think either you didn't mention or I didn't catch it. What was the size of your Corpa and the time span? Because as you said now, Czech corpus was 20 years, right? And I found that English was quite long, right?
Yeah. So to start Czech corpus, we really took just a piece of it because it's some 2.5 million lines, and at about 15 million words, I think. German corpus, I'm not sure about the size in measured by lines, but it's some 50,000 poems. And Spanish and English corpora are much smaller. Spanish has some 5,000 as well as English has.
Okay.
But once again, from
I don't really want to generalize.
no. I mean, these are the entire corpora from which we picked samples.
Okay.
From Czech, it was from very close period because we don't want to deal with 700 or 300 authors in one experiment. But the formal criteria to have a consistent sample in terms of versification, it allowed us in German to have a rather small sample when compared to Spanish, where everything is written in 11 syllable lines. So so these are these were the sizes of a corpus from which it was grabbed, these samples, and this is a description of the samples and the authors. where each sample is being 100 lines or 98 lines long.
Yeah, because I wonder how much the result would vary depending on time period, for example, or the amount of training data.
Yeah.
But this is just some idea
Yeah, we
to
don't know.
follow up. Yeah.
If I may ask a slightly technical question related to the feature space, I mean the number of words that you use, word features that you use, because the reason I'm asking is that in the delta-like methods, when you've got very long vectors of features that do not contribute, and just a few that do contribute, say the versification, they might be overwhelmed with noise, right? Whereas in the SVM support vector machines, the problem is slightly different. Namely, when the number of features is too big, it might get just wrong. Sometimes it does, sometimes it does not work. So yeah. So how big was your feature space?
Yeah, this was, you know, with the words and trigrams, it was some, it was 100. And with the versification, it differs according to.
Something like that. So the combined vector was like 300.
That's about 300.
350 something.
Up to 300. Yeah. Once again, I don't want to generalize the better performance of support vector machine because I believe it also depends on the setting of samples. You know.
But that's understandable. It should work better.
I mean, in each case we have pretty enough samples per one class, per one author. This is a situation which I believe perfectly fits support vector machine.
Exactly.
Once we have 2 or 3 samples per author, we may expect Delta family to perform perhaps better.
Yeah, so thank you for a nice talk. Very interesting things you were saying. And I'm not sure if I have anything very smart to add, but I'd like to share a crazy thought maybe. So my point is that I'm not really sure if I'm completely sold on the idea that diversification is actually a stronger feature than the others, and I'll try to explain myself. Okay, I have to admit also that I really don't know anything about literature or poetry, so I'll be just shooting around pretty much. But basically, for some corpora, you can see that your best methods. I mean, the most technologically advanced, which is certainly support vector machines. That, for example, for the Spanish corpora, right? You can see that versification is on par with words, and that the combined is the best, obviously, but it's only worse with different frequencies. So my point is pretty much that it might be that actually, if you use some sort of a more advanced computational technique, it might appear that versification is not a good feature anymore. Do you see my point? It's more like probably if you're reading poetry and if you like poetry, you have this you might have this hunch that versification is a very a powerful tool of saying something about the author because well you can see it pretty much everywhere around the poem, right? And words are words. I mean everyone uses words. If you'd have to devise an experiment which would be, in a way, okay, sorry if I sound blunt, but if you'd like to devise an experiment which would be less of trying to compare different computational techniques of trying which feature is better than the other, how would you try to prove that your intuitions about versification versus other features are stronger? Not stronger, are more agreeing with the reality. Do you see what I'm trying to say?
Sorry,
not really.
I'm afraid I don't get it somehow.
Hold on, I'll try to reiterate. So my main point is pretty much something like this. the fact that versification can be a very powerful feature is based mainly on our assumptions on reading, right? On our I don't know how to say this, intuitions about what's the style of the author or something like that.
I mean, this hypothesis was based on
Exactly.
this something like that.
And your experiments can be seen not only as comparing. What I mean is mainly is like that. There is another dependent variable which we should not control for in your experiment, and that's basically different techniques of measuring the validity or the accuracy of your results, right? Because well, comparing different distances, that's just a very basic technique, right? But if you try to learn to use the features to learn some more complex algorithm to see to try to predict the authorship, it might turn out that actually versification is a less powerful thing than I don't.
And do you include support vector machine into this more advanced or not?
Yeah, I think so. It's certainly it's a more complicated algorithm than just using a distance, right? Just if you try to give an example of an experiment in which you would control for these factors, such as more complex algorithm versus less complex algorithm. Do you see my point? Could you try to imagine an experiment like that?
And didn't this comparison shows the difference between the
for me, really, because how can I know that deeply recurrent neural network is not better?
Sure.
Right.
Perhaps yes. Sure. Perhaps neural network will perform better.
Mm-hmm.
If you ask me how to design such experiment, I would say in the very same way, isn't it?
Okay, it might be just too complicated for me to convey my thought, but thanks, that's okay.
No, if you ask me if I would ever been working with the neural networks in stylometry, I did not. No.
I think we can generalize this question and ask how much depends on the data set itself and how much on the techniques we use, right? So if there's any way of controlling for the techniques,
that's something. It's very, very close to what I meant, but more like not on a data set, but more like on the features versus the techniques, right? So how much the given comparison, the given accuracy depends on the given features versus the given techniques. Something like that.
And I think this is a little bit like the problem that if we want to see a particle in nuclear physics, we affect the experiment by the fact that we want to see that. Right? So we might be very close to that problem here.
To extend your set of stress-related features. So now you have the binary features stress, no stress, stress, no stress, stress, no stress, right? And another point of view on it is the distance between the consecutive stressed syllables. This is the syllables. So number of syllables between the stresses.
Mm-hmm.
That is implicit in your data now, but you don't have the specific and it may improve your results.
That's another way of measuring, another way of approaching it.
You can add it to your features.
Absolutely. I so far I was comparing this simple, stress per syllable with taking each line or taking a half line as a strings of zeros and ones and counting the frequencies of these strings, which gives you much more number of possible values. But this one turns out to be, at least with these samples and these methods, to give the best results. Probably just when dealing with 100 lines and taking the strings 0, 1, 0, 1, it's a rare feature. Once again, it's extremely rare feature.
Seems no other questions, so thanks again. will say something about the next presenter. Next.
Yes, I will actually.